All right. Let's get it up now. All right, guys. So just doing a review here. Um, so from January, we have been looking at vectors, and we just reach a parallel vectors, go in the same direction, know how to add those. Those are the simplest vectors. Let's look at the second one. Adding parallel vectors, some more examples here. And of course, finding an unknown vector. Because you'd have to find out which three vectors in this case would add up to one to this number here. All right, so that's parallel vectors, guys. This is another example of parallel vectors here. Notice that the answer, when we add vectors together, the answer that we get is called a resultant. So and so any vector that we add together is a resultant. All right, everybody hear that? So any vector added together is a resultant. The answer is a resultant. The vectors that are added together, like for example, the 6, the 18, and the 9 in this case, these are called components. All right, so let's get this on the screen here. We're gonna use a different color here. All right, so this is actually a component. All right, component. So, all right, so that's basically what it is. All right, so adding vectors together gives us an answer called a resultant. All right, the vectors that are added together individually are called components. So that's the information there. Let's continue. Same direction as we say, and we add them together. And then look at this. We have vectors that go in opposite directions. We call them anti-parallel. Just reviewing this, guys, for the SWOT test. All right. Possible questions. All right. Does everybody have these notes?
No, sir.
So you have to get these because these could be on SWOT. Abigail, Nayoka, Chrisanti, you have these notes?
Yes, sir.
Sir, I think so.
Yes, sir.
Yes,
Is
sir.
there Karika there? Okay, good. All right, just informing you, this will be on SWOT. And that's why you have these. All right. So what I'll do then, I'll send this, but I think I'll send this in the group, Let me just check the group because believe it was sent. It was sent in the classroom. It was sent to the classroom, was it? Not seeing it. Yes, it was. All right. January 22. Some notes were sent. And so it's in there. All right. Anyway. So, all right. So far, we're up to 5 persons here. All right. That's a little progress there. All right. So, can I move on from this?
Yes, sir.
All right. And let's just continue to the other slide. That's all right. Was 11 there. All right. The resultant here. These are just questions that you'd have gotten in class. So, you have been getting some practice here. I'm adding these vectors, but notice that in the anti-parallel vector, you're going to have at least one, you're going to have at least one vector that is going in the opposite direction to the others. So like this 5 is going up, this 8 is going down, and this 10 is going up. So what we do in this case is that we add the two vectors going in the same direction, and we add them and we get 15. So, and of course the 8 is going in the opposite direction. So when vectors are going in the opposite direction, we subtract them. And that's the idea here. But and what happens now? We subtract the smaller one from the larger one, and we keep the sign of the larger vector. And that's the rule with anti-parallel vectors, guys. So you guys going to have to go through your notes for these and try to remember it for the SWOT test on Thursday. All right. Any questions, guys?
No,
No,
sir.
sir.
Okay, let's go ahead. All right. So, all right, and this was a good class. We had quite a few persons attending this one. So,
And it's not on here.
all right, all right. This is the 11th. All right. So, I don't know what happened those days, but all right, and we went ahead and we also did more practice here. Showed you the resultant here, and so quite a few in bits of information here, and you get a question like this. No, boxes pull the two forces of 20 and 30. Now, what you're going to understand, guys, is that I'm going to write this here since it probably wasn't said before that force is a vector. All right, what you probably hear the word force before, but you're gonna learn today, and you probably should have learned before, that force is a vector, is an example of a vector. Um, right, force is an example of a vector. I always remember that. So we don't have to tell you that it's a vector, because once you say force, you're just going to say, oh, it's a vector. All right. So remember that. And force is measured in newtons. So you guys remember that force is measured in newtons. So in the questions, they will just say, all right, look at this. A box is pulled with two forces of 20 N. And remember, force is measured in newtons, and the symbol for newtons is a capital N. Capital N, guys. All right, so box is pulled with two forces of 20 newtons and 30 newtons, respectively. The box encounters a frictional force of 50 newtons. All right, so I use this question to show you that friction is a opposite force. So like questions like these now, guys, they don't have to tell you that it's anti-parallel, because you learn that anti-parallel vectors is what? Two vectors that go in opposite directions to each other. Well, friction and force, they are opposite to each other. So whenever I say force and friction, you're gonna say to yourself that, oh, this is anti-parallel vectors, right? So you always subtract the friction from the force. Hope everybody is hearing that. All right. Always subtract the friction from the force. If there's no friction, it means that you don't subtract anything from the force that is applied to something. All right. So always remember that. Question says here though. So the two forces here is what? 20 and 30. Draw, and then it say here the box encountered a frictional force of 15 newtons. All right. So all right. So friction means that. So what we're gonna do with this 15 then? All right. So that's the question here. Two forces of 20 and 30. All right. So question says 20 and 30. Think I'll show you the answer later on, but this is what the answer would look like. All right. But you seen this?
Yes, sir.
All right. Now two forces there of 20 and 30 going in this direction, you're pulling it. And in that direction, friction is against that, so you're going to subtract 15. So all we did here was what? 30 and 20 is 50. We subtract the 15, we get 35. And that's how you answer this question. All right. So does everybody understand this, or do I need to go over it?
I understand, sir.
Okay. All right. Wonderful. So we can continue then. All right. And afterwards, guys, we looked at the perpendicular vectors here. All right. Perpendicular vectors. And that's the definition here. These are actually vectors that act at right angles to each other. All right, right angles. So that's 90 degrees to each other. So this, for example, the three acting towards the left, towards the right. It's actually from left to right. So it's actually towards the right. And then afterwards, the other vector is going downwards. So you can look at this as if you're driving on the road and you're driving through like a lane or a street, and them tell you say pass three house, and then after you pass three house, then you make the next. So you turn left or something like that down the road. So it's gonna look like this. You're turning it's like you're telling somebody some directions. All right, so go three houses down, then you take the next right. You carry down here. So it's like you're going this way and you're going this way. So let's represent this if it was a road. So it'll look something like this, and then the road would have said so, and then now when you reach one, like a turn off, it'll look so. So notice that the vector would be saying then there's some road set like that still. So if you're giving persons directions, then it's good to know vectors here. All right, so then say so you pass three house, so the three house them could be here, and then afterwards now you go pass two house, so two house them would be over here. All right, and of course this would be like your vehicle. So let's just put all right. So that could be somebody walking as well. So you're walking on the sidewalk, you pass three houses, 1, 2, 3. All right, going towards that side. And then afterwards, now you're going to turn and pass two houses, the next side of the road. And so this will be a 2, this will be a 3. All right, so 3 plus 2 now. It means, you just start from here, so, and end up right here, so. All right, seeing Andrew here, sitting Andrew. All right, so this is actually how vectors work out in real life, guys. Giving directions. All right, because most time when you're showing persons where to walk or where to drive, you use your hand and your point. All right, so everybody in this class can give directions, good?
No, sir.
No? Tiana, you can't give directions?
No, sir.
All right, all right, let me see now. Where you live?
Sir, I live New Hall.
New Hall, I live.
Yes,
All
sir.
right. All right, New Hall, is New Hall far from Mandeville?
No, sir. Sir, it's 10 to 15 minutes drive away.
10 to 15-minute drive. All right.
Yes, sir.
All right. Fair enough. Where the farthest you can walk from to go home? You can walk from, if a 15-minute drive, you could have walked from Jarvis Valley Square.
Yes, sir.
How long it would take you?
Sir, I don't think it would take me that long, sir. About near to 10 minutes.
10 minutes walk. Cause you walk fast?
Yes, sir.
Well, all right. Cool. So like if somebody there at Jarvis Valley Square, you could have direct them to your house? If I want them to walk?
No, sir.
All right. Well, just trying to find out something there. All right. They say nobody good at directions. Abigail, you can give direction.
No, sir.
All right, can give direction. All right, where you live?
Mike told you, sir.
Mike Town. All right, Mike Town. You direct somebody from, let me see, Mike Town, you can direct somebody from Greenville and the gas station at Greenville to there.
I think so, yes, sir.
Think so. All right. So suppose then. All right, let us say. Suppose it's one of your friend then. Where that time for go?
So if the gas station in Greenville, sir,
Yeah.
I tell them to come straight, sir, because the taxi drive from Greenville, sir, say come straight. And then once they reach like the church now, sir, they take a left turn going down. And to get to my house now, sir, they take a right turn going up. And then they'd reach.
Got that. All right, class, understanding direction there. Think you could have find it?
Sir, me would understand you more than anybody else, sir. So,
Eh.
because here one time.
Oh, so you have been to Abigail's house already?
So, on a really good year, sir. So, it's
Mm.
like, sir, my uncle bring her there, sir. So, me kind of remember
Oh,
the way
oh,
it was there.
cool. All right, look at that. But then I guess everybody else know what I say. What you talk about? All right, but well, I mean, cool. But the point is that when you learn vectors, you're supposed to can explain direction easier. If even if you can't talk it, but you probably can. Well, you probably can at least draw it or something. But that's anybody. Everybody hear about Google Map?
Yes, sir.
All
Yes,
right.
sir.
Okay, good.
Yes.
Everybody hear about the one for iPhone name again. Um, a Siri use to find direction on iPhone. All right. Everybody have iPhone, but but all of those things on the phone actually use vectors to tell you where places are. You know. Um. So I'm seeing there nobody. No, the reason I'm asking you these questions, I want to see how your knowledge of vectors is if you're giving directions. All right. So nothing wrong there. Karika, still there? All right. Naoka, Chrisanti.
Sir, really answer now, sir. I never unmute my mic, sir.
Oh, yeah, Percival. Yeah, Percival. Where you live?
Where me live, sir?
Mm-hmm.
I live a Billier, sir.
Bellier. Okay. Well, all right. So is it far from school?
No, sir, not that far. Me, I can't walk to school, sir.
Okay. Cool. So you can tell anybody easily how to find your house then.
Yes, sir.
So all right, where you tell him? Where them there at school now? Where you tell him to go?
Yes, we got a Billier, sir.
No, but you can't tell him that they don't know a place. Percival, everybody know a place. Percival, come on, man. What instruction would you tell them?
All
How
right.
far they must walk go?
Let's see. Walk straight. What's it now? Wait, listen.
Mm. Okay, if you say walk straight, no, then you know.
Walk straight. Walk 2 mile. Not 2 mile. It's about half mile, sir. Half mile, then I see a next road, then I take left, then I walk. Boom.
Hold on. Me think what you saying now, Percival. If based on those instructions where you tell me, if you say take a next road, the first road we say after Belfield, towards the field, You see what I talk about? The first road. If you walk straight and you say one next road, and you say take where you say left, you say?
Yes, sir.
Right a field that I care upon.
No, sir, that mean, no, sir.
All right, go on then. Talk what you mean then.
All right, no, see no. Sir, no, sir, 2 billion they have not true, sir.
Yeah, cause I know the school right down the road from Woodland. This so.
I know it other billion true, sir.
The Billy right near Belfield.
Yeah, and that billion may talk, sir. Other billion, sir.
Oh, never know say there was another Billy.
I know people don't know that, sir. But
Billy. Interesting.
some people call it a mango grove, sir.
Oh, no, we never hear about Mango Grove. But that is that near to Coffee Grove?
No, sir.
Oh, okay.
Near to Bombi, sir.
Bombi. All right. No, you're talking now. No, you're talking. But then for everybody listening now, they would have different idea of the place because I would know because we kind of know from school up to a certain point. But all right. Just hope say just understand this though that vectors is what make giving direction easier. All right, you're telling persons exactly where to go and you use numbers to do it. So so like I'm saying here in this diagram, if you see it on the screen, I'm doing question A, putting it in real life situation here. So a person is walking from where them start here. So you tell them they must pass tree house, right? Right. And then they want to take the next turn off. Where you point the arrow, so they won't have to ask where. And so them take 3 forward and then 2 downwards. And them supposed to end up at a certain point. So that is the idea with the vectors. Now, these are what we call, what name we say we give to these vectors again? When they act this way. We get a vector, one going in right angles to another vector. What name we give to those vectors?
What name give to them?
So it's a 3. See, you see it now? This is a question for everybody, you know. So if you don't know this, it means people them not understand or them not listen.
Sir, repeat the question, sir.
The question say, what name we give to vectors that are at right angles to each other?
Sir, last class they teach sir.
No, sir, no last class. That teach from January. I revise because now I go get SWAT on Friday. Not Friday, on Thursday.
Oh, that makes sense. I know that thing.
So so you see, so one day of learning is taking place, but this was done from way back in January. I mean, even talk about it before this. So as we say, probably when distracted or you know, you don't understand the words I'm telling you. Maybe I'm talking in unfamiliar language, but English is the only language I know. So can't help you out there.
Sir, perpendicular vector, sir.
But a long time if you say that. So I don't know why everybody keeping silent. All right. So these are perpendicular vectors. Just talk about it a while ago. As a matter of fact, see it there now. Go back to scroll out of the page and show. See there? Perpendicular vectors act at right angles to each other. I'm gonna do a zoom in and then don't forget what you said before. Look at that. Anyway, that's perpendicular vectors. Anyway, so let's get out of this now. To add perpendicular vectors, we do the following. The first step is to draw a scale diagram. So again, for the SWOT test, you now go well. And see how you're going to be able to draw vectors there. You could and then you post it. But I'm gonna see how that go. But then when you're adding perpendicular vectors, you don't do it like the other one them where you add a subtract. What you do here so now is you can draw the first diagram. So for example, them say add 6 going up to 4 going towards the left. You draw the 6 first, but them say draw a scale diagram. Let me underline the word scale because and if you understand what scale mean. Right. So scale in this case means you're gonna use a equal measurement. You're gonna use a ruler. So you're gonna line up your ruler. Let me even draw one ruler and show you. So how the ruler stay. Ruler will stay something like this, and you're gonna measure 1 to 6. So you're gonna do something like this. Even draw the ruler on different way. Because you see, no, nobody said sir never teach, and I show you with the ruler here. So this is 0, this is 1, 2, 3, 4, 5, 6. All right, could even carry the ruler up some more. All right. Yeah, so this is 6 then. So this is call it 6. So you basically do something like 6 centimeters with the ruler. All right. So this is the ruler. All right. But you understand what to do here, guys? You seen what I'm showing you? So
Yes, sir.
then you say add a vector where it goes 6 up and 4 to the left. You draw the 6. So you have to take your ruler, draw this. Take the same ruler after you done draw that and turn it towards where the arrow safe will go, which is the left. And you measure it up. So this must be 4 centimeters and this must be 6 centimeters. Use a ruler. All right. Everybody get that? That's step 2. Yeah, that's step 2 now. All right. Next one now. Step 3. All right. Complete the triangle to close the vectors. All right. So after you draw the 6, so you take a ruler now. The same ruler where you use draw the 6 first, then you draw the 4. You're going to take the same ruler now and measure this distance. So you're going to turn the ruler crossways. So let's see if we can draw it. You take your ruler and measure this line here. So this line where you see drawing the yellow. You're going to use a ruler and measure that. All right. And then whatever answer you get with the ruler is the answer. Measure the length of the line with a ruler. This will give the answer, which is the resultant. All right, that's it. Any questions here, guys?
No, sir.
No, sir.
All right. So that's for vectors. And then this was the homework given to give the answer there. All right. Again, I don't know how many persons did it, but all right. Another way to solve perpendicular vectors is to do the following without a ruler. So if you don't have a ruler, you can do it this way. Again, a few persons were at that class, but we did it. If you don't have a ruler, then this is the way to do it. Multiply each vector by itself. All right, so let's see if we can get an example. Without a ruler. Everybody seen this?
Yes, sir.
All right, so see it then on step 1. You say multiply each vector by itself. So you have 6 going up and 4 going towards the left. So you're going to say 6 times 6, and then you're going to add that now to 4 times 4. All right, so that's step 2. Add the two numbers. So I get 36 plus 16, and that will going to give you 52. All right, then the third step now is to find the square root of 52. And then you'll get 7.2. And that's your answer here. All right, so you get 7.2 for the vector. All right, now, any question here? So guess what now? What it means is that if you do it this way, then if you do it this way, you're supposed to get the same answer as when you do it this way using a ruler. So the question there, it's actually using a ruler. And using a ruler give you the same answer as when you don't use a ruler. Just follow the 4 steps. All right, so that's with the ruler, and this is without the ruler. All right, any questions?
No, sir, but may I write off the step them, sir?
All right. I send that. Are you writing it up now?
So yeah, put in the classroom, sir.
Yes, I'm gonna send it in the classroom.
Okay, sir, we can write off at time then, sir.
Okay. All right. So these would be the steps you would want to write off. These steps, 4 steps. All right. So all right. Now that's just vectors. You get a few vectors to solve this way. So not going go much into it though, but let's look at the question that was given. Let's scroll out and make you see what's happening. All right, there you go. Find the result of the following vectors. You have a vector 4 and 5 to add together, but they are at right angles to each other. And you see the right angles whenever we put the arrow them together, as how them stay in the question. If them stay like this, then it's a right angle. So that's gonna be perpendicular. All right. So all right, perpendicular. So then therefore you're gonna have like a 4 and a 5 here. So that's perpendicular. So you know say All right, if I don't have a ruler, you just square each vector, which is 4 squared, which is 16. And look at this, 5 squared is 25. And then you add them together, you get 41. Square root of 41 is 6.9. And that's the answer. That was without the ruler. And then if you were to use a ruler, you'd do it like this. It's 6.4. Not sure why 6.9 was there. All right. Sometimes sometimes the measurement with the ruler might be off depending on how straight you draw the line. So be that in mind. So but if the line draws straight, you're supposed to get the same answer. All right. So all right, so that's it now. So these are just some examples here. Again, this was for the end of January. And then we started February doing this.
Right.
Yeah. And so this was for February. We would have started with vectors and then finished that, and we started this topic. So we looked at derived quantities and derived units. And then we tell you the difference between a quantity and a unit. So, all right. So quantity is what? So something that can be measured or counted. All right. Unit is the standard, like how it is measured. So these were the examples here, the basic ones, which we never even did finish because probably class it up or something. So anyway, what anybody remember what is the unit used to measure mass?
Kilogram.
Okay, very good Christianity. So let's go kilogram there. All right. What's the for time?
Second, sir.
Seconds. All right. And what is it for electric current?
Ampere.
And let's go with that. And then for temperature is what?
Mhm. Temperature. Thermometer.
Celsius.
No, Tiana, not Celsius.
Temperature. So me know. And not temperature. Have why? Kelvin, sir.
Kevin, you see how long it take to find that? So, all right. All right. So the answer here is Kelvin. So then these are the basic units. So, all right. So that has something to do from last year still, no? So, don't know what happened to the brain and the information there. Maybe something happening. Not sure. But all right, quantity here. All right. This is how to how we derive quantities. So how derive quantities. Quantities and units. All right, are obtained. So this is how you get them. All right. So how do we get derived quantities and derived units? It's double underline quantities and units. All right. First thing now, take the quantity now, guys. So we have length. If you multiply the length of something by the length of some other part of the same thing, sometimes we call that part the width. Then we get something called area. All right. Anybody learn about this in math? Learn about that in math? Anybody know about area?
Yes, sir. I learned not much, sir.
All right. So that's a derived unit. because you're getting a different information about something. So when you derive something, it means you're getting something different. So the length times the length, or in this case, width, that gives you area, which is a derived quantity. So then it asks, what is the derived unit for area? You're going to take the units now that length is measured in and do the same thing. Meters times meters, when give you meters squared. Everybody see that?
Yes, sir.
Yes, sir.
All right. Now, so area is derived from length. Area is defined as the amount of space taken up by object in 2 dimensions. All right. So that's it. So that's therefore area is measured in meters squared. And then this was where we stop. So we talk about length, but as we say, as a rule, when you get a derived unit is obtained. And let me see if there's information further down there. All right, I'm gonna have to go put it here. So then, all right. So a derived unit is obtained when. Right, so basically you have two, when two or more units are divided. Right, so you divide them or multiplied. All right. So yeah, multiplied. All right. So all right, by each other. All right. So example here, you just say that we just say that meters times meters give you meters squared. So that's a unit. Meters times meters give us meters squared. Is equal to, you could also say m times m, which is the same thing as m squared. The meter squared. But then what if we got something else, like when we divide? So I'll go back to the base units and we can see what's happening here. All right. So what about if you multiply the length by itself twice or 3 times? So let's see what that would look like. Another example. So let's see. Also, we can do this. Length times another length. Let's call this one width, just like we did a while ago. Like if it's a square or something like that. But what if we have this now, another length, and we can call this height? Right? Then what would this give us? What would that give us? So that's gonna give us something else, because we just multiply length by itself 2 times. All right, length times length give you area. But then if you go back again and multiply length by the other length by another length, we're going to get something else. So what is that called? All right. The question is now, how people know how big them house is? All right. How people know the size of them house? Some persons might say them live in a big house, some might say them live in a small house, some persons might not know. But how can we be sure? All right. May I ask you this question? Is Belfield a big school?
Yes, sir.
All right. So Percival is saying yes. Anybody else saying yes? Belfield big?
Saying all that big.
All right. You say not all that big. You say which other school you know bigger than Belfield?
Sure, the primary school I usually go to
Which is which one?
St. Patrick's Parish.
All right. So you're saying St. Patrick's Primary is bigger than Belfield?
Yes, sir.
So how you know that? Where you take and say that?
Well, sir, sir, I don't know how to explain, sir, but I'm not say bigger than the sir.
But you see, you can't know that. You can't look and know. You know. If you even look and know, you have to tell me where you look on. So I can understand why you say it bigger.
Sir, the grounds and the buildings, sir. Yeah, more buildings.
Yeah, more building. All right. All right. Well, all right. Point taken. And so are you sure say the building at the same height and the same width and everything?
Sure, I think so.
You think so? You think that's the thing. No, in real life, guys, you cannot think because if somebody pay you for build a house, you can't say me think say big enough still. No. You can't say that. They pay money and so contractor collect. You can't say that. You have to be sure.
Sir,
So-
I have to take a measurement then, sir.
You have to take very good. You have to take the measurements. No, these are the measurements I'm telling you that you're gonna take. You're gonna take the length, you're gonna take the width. Right. So what is length now? Length would be like how long, right? Then you're gonna say width no, width means say how wide. So I'll do something like this, right? So I'll show you say this is length. All right, and here so it's width. Everybody seen that?
Yes, sir.
Yes, sir.
All right. So what shape this look like to you?
Let's see, like a rhombus, sir.
All right, say call that then. All right, watch this now. What is the third thing I multiply over here? What is this word over here?
Sir,
Last one,
length
sir.
or
Huh?
sir, length or height.
All right, so that's the height. So where would the height be? What is
Side,
the height
sir.
of something?
Sir, how tall it is.
How tall it is. So therefore, you'd have to go up. So then, no, so you'd have to go up.
Yes, sir.
So these are the height. So then again, all right. So with the height now, of course, you still are gonna have the length because the height would have be if you're gonna build a roof over this, you have to go make sure say the top covered. So it are gonna end up with something like this. You end up with something like this. Right? And see they know you end up with what? Something that look like box. And they know where you gonna call this now. So that's the thing. These are things that you should where is it? Let's see the eraser there. So all right. Anyway, so the point is then that you're gonna have length. So you have length times width times height, and that have a name. And after almost 4 years of school, you don't know that. When I write the answer here, that's called volume. All right. Anybody ever hear about volume before?
Yes, sir.
All right. So length times width times height is volume. And volume is a derived unit. All right, derived unit. So it's another derived unit. All right. Any questions so far, guys? But another question. You better make sure so you know what volume is. Volume is length multiplied by itself. All right, length basically multiplied 3 times. Length times length times length. All right. And sometimes we call one of the length width and we call another one the height. All right. So length times width times height. All right. That's how they derive unit. All right. Now the next thing is that you'd have to know what volume is. So, what on earth is volume? All right. All right, let's just take off that then. What is defined as? All right, so you can have many definitions for volume, which you can say area times length. But you seen that?
Yes, sir.
All right. You can also say, so it's area times length. You can also say that it is, yeah. You can also say that it is the space taken up by an object in 3 dimensions. The space taken up by an object in 3 dimensions. All right. So these are ways you could define it. Let's see. You could even say, but then the third definition not when given no because might mash up your head. So let's just take it easy and just give you these two. All right. So volume is defined as area times length. All right. I can say the space taken up by an object in 3 dimensions. All right. The 3 dimensions again is the same thing as saying length, width, and height. All right. Now, volume is measured in what? Because if we say the same thing you do today, the quantities. If you was a length times length times length, what is the unit for length?
cm square. So centimeter square, sir?
It can be centimeter square, sir. That is not the plan that is not what we're working with. We say anything you do today, to the quantity you're going to do it to the unit. It can be squared. All right. Length is measured in what?
Length is measured in meters. Yeah.
All right. So you're going to do meters times meters times meters. What that give you?
So meter times meter times meter.
Yes. How much time we did multiply meters?
Cube
sir.
meter, sir.
Thank you very much. It's meters cube. So you're 3, you're going to write M and put 3 up there because you multiply meters 3 times. But you see that?
Oh.
Yes, sir.
All right. So that is it. That is simply what we're talking about here. Volume is measured in meters cubed. All right. And that is written as M to the 3. Simple as that. All right. So I would say, guys, when you're learning these things, if you don't understand, you need to say something. All right. Or just remember, say if you're not focusing in class, then a time will come when you're not gonna know the information. And the easiest thing for students to say when they don't know something is one, it wasn't taught. Or maybe let me say, them couldn't hear, like how this online thing set away. But I'm pretty sure that on my side, the video is clear. So I'm gonna I just send the link to of this class in the group as well. So bear in mind still say, let me say, guys, what you put in is what you're going to get out. So Seeing that this is where we're going to stop for today. All right. Remember, we're just learning what volume is. We're learning how we can define volume, and also we're learning how volume is derived. All right. This is just like continuation. All right. Let's go back to the register and see who. All right. So this is third of the first. So who should be added to this now? All right. So I'm seeing Percival here, and I'm seeing, well, Andrew was on, but he's off now. And then I'm seeing Ricardo. All right. So yeah. So Andrew Stewart was there, but he would have had trouble. Sorry, him exit, whatever the case is. One, there's also Kairika. I didn't add Kairika. And of course Ricardo. So not a bad attendance today. I wish classes were as this amount or more, and Christian is still not here. So, but as we say, guys, you see, not if you don't come to class for a subject like physics or chemistry, it is going to be very challenging. It's not like other subject where you can send notes and read it. Physics and chemistry is not that type of subject. So I'm telling you, dozens of times say that is the situation. So I'm say if you want to get the subject to get recommended for the subject later on this year, these are the little things that will be used against you if you miss class, if you don't participate, if you don't communicate, all of these things will add up, guys. So be careful, because usually when time come to get recommended, a lot of students begging to get recommended, and I'm not afraid to say no if personally the teacher I forgot defend for them, them reputation. Because I'm used to having students pass in my subject, and if you begging me to do the subject and you don't show me where you're going to pass the subject, or you're learning anything, then I'm gonna say no. And um from there, the only option you have is to either make some other teacher recommend you, but you'll be doing it under their name, not mine. But it's not a nice feeling when your friends get recommended and you don't get recommended. Or when you check how much subject you get recommended for, it's only about one or two. You know what I mean? It don't look good. You do that mean say you'd waste 5 years of school. And even though it's an online thing, doesn't mean that we stop learning. It's just that you have to learn differently, and you have to just adjust to the difference. All right. So I'm gonna try my best, as we say. So the information here, I'm gonna send this in the group or in the classroom, and I'm gonna see if I can get the video together as well and send you the link for it. All right. So it should be on YouTube though, so you can go and see it once I send the link. All right, guys. So any questions?
No, sir.
All right. Okay, so we're gonna finish for today. Um, so thanks for coming out today, guys, and look forward to seeing you on Thursday. Remember the SWAT exam on Thursday. All right, enjoy your day.
Thank you, and same to you, sir.
All right. Thank you. Okay, thanks. All right.